So for the final section of Unit 4, we're going to see where do we use slope, rate of change, y equals mx plus b. Where does all of this get used in the real world? So we're going to apply our slope-intercept form to real-world situations. Now you might remember this DJJD. Matter of fact, a lot of what we've done today you've seen before, and we're just giving those mathematical names of slope and y-intercept to things that we've already worked with before, so don't be surprised. So just before we get started, let's remember what the slope-intercept form is. And I have a line over here, and what I'd like you to do is write the equation of that line. So I am looking for a y equals equation. See if you can do that. Okay, so the first thing I would have noticed is that the y-axis intercepts this line at +4. I would look for 2 points in the crosshairs, which I nicely marked for you. I'm going to get in my leftmost one. I'm going to enter right here, and I'm going to rise 1, 2, 3, and I'm going to run 1. My slope is 3 over 1, which is 3. My y-intercept is 4, and I write y equals m, the slope was 3, x plus b, and there's my equation of the line. So we're still going to be talking about slope and y-intercept in that slope-intercept form, but now we're going to talk about it in a real-world context. So we're going to remember this y equals mx plus b, that there are basically 4 things. 2 of them are going to be variables, and 2 are actually going to be numbers for a given situation. So the y is going to be what we call the output or the dependent variable. He's waiting for the math to happen. The x is going to be the independent variable. That is the one where you can pick numbers for. And then you do the math, and then the output would be the y. The number in front of the x, called the coefficient of x, is called the slope or the rate of change. How much does something change? Oftentimes over time. And the b is the y-intercept or the initial value. You know, if there's a phi involved, that would be an initial value. So let's look at some examples. And let's start with one that we've already done before. So before we ever talked about slope or y-intercept, you guys did this problem where you had to write the function rule. So in this particular case, remember it was the student council is planning a dance marathon, and DJJD charges $100 to bring all of his equipment and set up. It takes him some time. And then he's going to charge you $40 per hour to DJ the dance. The total charge for the DJ is modeled by the function what? So we need to write our input-output function. And you did this one before. So remember that the output, which is y, and in this case, that represents what? It's going to represent the total cost in dollars that you're going to pay the DJ to do the dance. Now, the next thing we're going to do is we're going to look at these 2 numbers, right? And remember that m is your slope. Slope is movement. Slope is change in y over change in x, right? In this case, which one of these numbers is showing you that? And which one is the initial value? So in this particular case, the slope is your $40 per hour. Dollars per hour. Your y unit is money. Your x unit is hours. So the slope is 40, and the x represents the number of hours. What is that 40? That is your hourly charge. So 1 hour, your bill goes up $40. For 2 hours, your bill goes up 80 hours. So every hour, there's an increase of $40. What's the y-intercept? In this case, it's the $100. It's that initial value. It's the setup fee that you're going to pay no matter how many hours. You're going to have 100 plus the number of hours times 40. So our equation would be y equals mx plus b. You guys, like I said, did this without understanding that 40 was called slope and without understanding that the 100 is the y-intercept. You understood that in the past. So basically, as we go through, You're going to have to define, what's the input and what's the output? Who's the X and who's the Y? Usually you ask yourself, what depends on what? If time is involved, seconds, months, hours, years, it often is your X or your independent. So dollars depends on how many hours, not the other way around. And then you're going to figure out what the slope is, which of the numbers in the problem or on the chart represent the slope, the rate of change, something changing. And the B, the y-intercept, is that initial value, and it's often described as a fee or a startup fee or an initial deposit, something like that. You're going to use your slope and your y-intercept to write your y equals mx plus b. We can graph it if we want, and then we use the equation or the graph to answer questions. So we're going to see our linear relationships in words. We're going to see them in function rules. We're going to see them in tables. We're going to see them in graphs. And we're going to work basically with all four of these as we go forward to answer real-world questions. So we're going to start with a graph. So the title is important. It's the depth of water in a vase. Days is my X variable, and the depth in inches is my Y variable. And do you see that the water in the vase is going down over time? If you ever put flowers in a vase and looked at it a few days later, the water level will drop. So this graph shows the water remaining in a vase after several days. We need to figure out what the rate of change is. So right now I want you to look at the graph, and rate of change is a synonym for slope. So can you calculate the slope of the graph? All right, let's start there, and then we'll answer the next question. So you should have seen that you are dropping 1, dropping 2, dropping 3. I wrote it over here just because the numbers were kind of in the way, but you're dropping 3, and then you're running 1, 2, 3, 4. So you're going down 3 over 4. That means you're going down 3 inches every 4 days. To get a unit rate, you would take the -3 divided by 4 in your calculator, and then basically the water in the vase is dropping 0.75 inches, 3/4 of an inch every day. What's the initial depth that was in the vase? For that, we're going to go to your y-intercept, and we're going to see that 8 what? Is it 8 elephants? No, it's 8 inches. So you started with 8 inches of water, and every day the water level is going to drop 3/4 of an inch. Y equals m, which is that change, that movement, which is the -0.75. We're going to put that in front of the input variable, which would be the number of days. And we started with a +8. And so now we could say, after 5 days, you could put in a 5, multiply it by -0.75 and add 8, and that'll tell you how deep the water is after 5 days. Or we could come to our graph, come over to 5 days, come up, and it'll be a little bit bigger than 4 inches. Okay, let's go to another graph and kind of let you do this one. We'll read it together. So this is Music Inc., and it charges a yearly subscription fee plus a monthly fee. The total cost for different number of months, including that yearly fee, is shown in the graph. Determine the amount Music Inc. charges for the yearly subscription fee. So basically what we need to do is kind of take a look at what's going on. So after 1 month, you would have been charged $15. After 2 months, you would charge $18, and so forth. You can see the points on here. The X is the number of months. Y is your total cost in dollars. We're going to define our variables, and we're going to write an equation. So first of all, we're going to have an X and a Y. So X is going to be, it's really easy off of a graph. It's the number of months. And Y is your total cost in dollars. And anytime we write an equation with variables from now on in math, we always let everybody know what those variables stand for. So in this case, when I unveil this, the X would be number of months, and the Y represents your total cost in dollars, and nobody has to read the problem to see that. All right, so our total cost, which is our Y, has to equal, now remember we need the slope. So you're going to come back up here. Now it's kind of hard to block count, but I've got coordinates. So if you took y minus y over x minus x, you'll get the slope. So can you do that now? 18 minus 15 is 3 over 2 minus 1 is 1. So the slope is 3, and we're going to put that in front of our input variable, which is months. Basically, you're paying $3 per month. And then we need our b, but it's hard to see what that is here. So let's kind of see what's happening. Notice our y is going from 24 to 21 to 18 to 15. Remember that we're going up, we're adding 3 for each time we add a month. This time, if we go down, we want to get to 0 months, we need to take away 3. So the initial fee, that yearly fee, was $12. So to answer this question, the yearly fee was $12 and we're paying $3 a month. Can we use our equation to determine the cost for 10 months? Now remember, x is the number of months, so I'm going to put 10 in and do the math. 3 times 10 is 30. Add it to 12, and I will get $42. So if I was a member for just 10 months, I would pay $42. Okay, so now we're not going to look at graphs, we're going to look at tables and basically try to do the same thing. We want to come up with that equation, and that equation could be used to talk about things in the future. So in this particular case, you could be fishing, you could be cooking fish, you could be cleaning fish, I don't know what it is, but after 0 hours, the number of fish has been 10. So if you're catching them, when you started keeping track, you already had 10 in the bucket. If you're cooking, you already had cooked 10 when you started counting, but basically at 0 hours, there were 10 fish. We need to know, what is your input variable? Which one of these would be x, hours or the number of fish? And I'm hoping you said hours. The number of fish depends on hours. Your clock isn't going to change miraculously based on, say, how many fish you caught. What is your output variable? Well, that becomes easy. That'll be the number of fish. So now we're going to find our slope. Remember that slope is y minus y over x minus x. Find your slope, your rate of change, please. Did you get 3 fish per hour? Oh, by the way, you could have taken 16 minus 13 and gotten 3, and 2 minus 1, 3 over 1. So no matter where you pick in the table, if the table is linear, which they told you it was, you will get the same slope, the same rate of change. So basically you're catching 3 fish an hour. Now let's determine the initial value. What is the initial value? Did you say 10 fish after 0 hours? If you were to plot this point, 0, 10, it would be on the y-axis. This is your initial value, your y-intercept. And now you need to write your equation. Y equals mx plus b. And then you could say, if I stay at this rate, what'll happen if I did this for 10 hours? Well, 3 times 10 would be 30, plus 10 would be 40, and I'd have 40 fish after 10 hours. Okay, so let's do another one, and we're going to actually go all the way to a graph on this one, and then I think there's one more after this. So let's say you go to a zoo. I'm not sure if the Roger Williams Zoo does this, but I do know that the Pequot Tribal Museum, Mashantucket Museum, has an exhibit where you can rent an audio guide. And so as you're walking through, it will start talking to you. I've been in the Newport Mansions, same thing. And you can rent this audio guide, and as you walk through, it kind of talks to you about what you're seeing. So in this particular case, this zoo will charge a rental fee for you to take that unit. It basically usually hangs around your neck or you put it up to your ear. And the table shows the total charge for the various hours of use. So you have to pay like a down payment on it, and then you pay an hourly fee. And when you return it, they usually give you back the rental fee. So we need to define the variables. Here's a table, hours and cost. Which one is your X and which one is your Y? So your X should be the number of hours. Your cost depends on the hours, not the other way around. And now we need to know what the rental fee is. What did you pay before you ever walked away from the booth? That's your initial fee. The problem is it's not as obvious as our last example because I can't see the 0 on the table. Can you figure it out? So the answer is yes. If you notice you're going 4 to 2, you took away 2 hours. And if you take away another 2 hours on this table, you would be at 0, 4 to 2 to 0. So now come over here, 11 to 7. 11 take away, you're taking away 4. And if I take away another 4, I would get to 3. So sometimes if it's not on the table, you can back out of the table to get back to that 0 hours to see the cost. And in this particular case, the rental fee was $3. So you hand them $3, you take the audio guide, and off you go into the zoo. Now you're in the zoo for a while. What are you going to pay for every hour you rent that little audio guide? Well, remember, that's slope. So you're going to take y minus y over x minus x and make it a unit rate. And let's see how much you pay per hour. So 7 minus 3 would be 4 over 2 minus 0, which would be 2. 4 divided by 2, you're paying $2 an hour. So every hour you keep the device, you're going to pay an extra $2. So now you're going to write your y equals mx plus b. Slope goes in front of your input variable. That's your rate of change, $2 an hour. And that initial fee is your b. So how much would you pay if you rented it for 6 hours? Now remember that x is your number of hours. So you're going to substitute 6 in for x and do the math. And that would cost you a total of $15. 2 times 6, $2 for 6 hours would be 12. Add the 3 would be $15. So let's talk about what if we were going to graph this. Let's just go back and kind of remember how to graph a real world graph. First of all, we would need a title and we need some labels. So, a title might be audio tour guide rental. Now remember that your X is really easy to label. It's going to be your definition of hours and your Y would be your cost in dollars. So if we come over here, you can see there's our time in hours. And then over here, there is our total cost. And then we would have to talk about, how many hours would be reasonably. See, I'm kind of going half hour per block here. And remember that, in our table, let's just go back here, we're looking at getting to at least 11, if we head up to $15, so we're not going to be going up to 100. So as we go to do the scale, I'm doing basically $1, 2, 3, 4, 5. I can get up to $10 here, basically. Okay, now I'm going to graph it. And I can graph this really easily because I can just go and put that on my y-intercept. Notice I'm not even plotting points. I'm going to plot that and use the slope to move. So I'm going to come here and, oops, I didn't get my point, did I? There we go. I'm going to start there and I'm going to go up. I'm going to rise 2. And I'm going to run 1, but be careful, 1 is all the way over here, right? And there would be my next point. And then I'm going to do that again. I'm going to start here, and I'm going to rise 2. There's $2. And I'm going to run 1 hour, but be careful. Remember, each is a half hour. And then I'm going to draw my line. It actually won't be a line. It'll be a ray because I'm not going to put an arrow down this end and go into negatives, but I could keep, keeping that for more hours. And that's kind of what my graph would look like. We can either use our graph or our rule to determine, make a prediction on hours in the future. Okay, so let's take a look at this last one. And this last one is all in words. So we're going to use the words to write our y equals mx plus b. And then we can talk about, what would we do if we wanted to make a prediction. So it's one of those movie rental boxes, the red box or something like that. There's a DVD rental, which pretty soon are probably going to be gone. And it charges $2 to rent a movie. So if you take a movie, you pay $2. Now, if you return that movie late, they're going to charge you some kind of fee every day. So every day it's kind of like a library book if you're late or whatever. And in this particular case, this rental box is going to charge you $3 per day, quite a bit. So the first thing we want to do is we want to write our rule so that we can kind of see how much a charge would be, say, after 10 days or 20 days or something like that. So we're going to define our variables. What's the x and what's the y in this case? So if you find that $3 per day, dollars per day, there are your two units. One of them is going to be days and one is going to be dollars. Remember that if time is involved, it is usually your x, your independent variable. And also, if you hear dollars per day, dollars on the top would be your y, and days on the bottom would be your x if you think about it from a slope perspective. So x is going to be the number of days, and that's your independent variable, and y is going to be the total charge in dollars. So the dollars depends on how many days. That makes sense. So what is your slope? I kind of just gave this one away. And notice it's $3 per day. What is the initial value? That would be your $2 that you paid. Can you now write your equation, slope-intercept equation? Y equals mx plus b. So what if you were, say, 20 days late? 3 times 20 would be $60 plus 2. You would pay $62 for that silly movie rental. So that's not a good idea. So anyway, what we did today is we took our discussion of slope and y-intercept and our y equals mx plus b, and we wrote equations, function rules, from graphs, from tables, and from words. This is why we did all of this, to be able to take different real-world situations and be able to come up with a rule that we can use to make predictions. So now when you come into class, we'll do a couple together and then we will practice. I hope you all have a great day.